So what's it like video editing with the fastest AMD PC possible? This over there is the fastest 16-core AMD PC. Now I know you can go Threadripper and so on, but they're not as fast. We don't yet have Zen 4 Threadripper cores. This is the Ryzen 7950x and Radeon 7900 XTX GPU. And this is the Power Color Red Devil model, which is probably one of the best 7900 XTX models out there. Now what's the timeline performance like? Can it play back codecs up to 12K? Let's find out. And let's find out about the sponsor of this video. It went quite high.
Let's talk even higher, so that only dogs can hear us. And eventually there'll be one person can hear.
Looking for a cheap way to license your Windows? Check out Whokeys through the links in the video description. Make sure to use the code TN20 to get a 30% off. Paste the license to the activation settings and you're all done. This license is for Windows 10, but you can upgrade it to Windows 11 for free. They also offer Microsoft Office 19 license. Use the same code TN20 to get a 30% off. Check out whokeys.com in the video description below.
So then, we've got Premiere Pro open in the background, but we've got to talk about specs of the PC. If you want to check out the full specs or pick up any of these parts, I'm going to leave the links for everything down below. We're using the Ryzen 7950x CPU. We're using 64 gigabytes of Kingston Fury Beast RGB RAM. We're using Gen 4 NVMe for the OS and for the project drive. I'm gonna leave them down below as well. We've got Deepcool LS720 AIO with the best Phanteks T30 fans. We're using the Asus ProArt X670E motherboard, Phanteks Revolt X 1200 watt power supply, the Power Color 7900 XTX Red Devil limited edition GPU, and it's all in the Phanteks G500A PC case. Links down below if you want to check them out. So we're also going to be checking out the thermals and the clock speeds of the CPU, but most of all the timeline and performance, okay? This little green dot here shows us if we have dropped any frames or not, and we're playing back everything at full resolution. So this is 4K. If I'm not saying more than 4K, everything is 4K resolution. We're pressing play. This is pretty simple mirrorless camera footage, 8-bit 420 60 frames per second H.264, and we've got a color grade on there as well that's accelerated on the GPU. So as you can see, the GPU is playing back or calculating, computing that color grade there, and the CPU should be playing back that there. As you can see, video codec 0 is playing something of this back on the GPU because the CPU is pretty idle here. As you can see, only 6% doing nothing. Timeline performance is actually super smooth, buttery smooth. Next off, 10-bit 420, scrubbing, no problem. Slightly more choppy, pressing play. It looks a little bit choppy here actually, interestingly, but it's all right. This is a 10-bit 422, which is a little bit harder now to play back. As you can hear, the fans are kicking up. So this goes back on the CPU now. Played back on the CPU, let's see. As you can see, but no problem for the CPU to play this back. The 16 cores are easy. This is 25 frames per second. H.264 422 10-bit. It's quite hard to play back, but here's the thing. One of them is an all intra clip, the next clip there. So this is all right. As good as it's gonna get, what I've ever seen. But this is an SI clip, which is a little bit easier. As you can see, scrubbing is much easier, this one compared to this one. Both clips are on the CPU, but playing back very instantly. Scrubbing and clicking on the timeline is very instant. Moving on to 422 60 frames per second H.264. So this should, actually, when you're pressing play, that happens very instantly as well. Sometimes the CPUs take a little bit of time to start playing this. And as you can see, this gets played back on the CPU. We've dropped 3 frames. So interestingly, there is a little bit of a glitch where we are dropping some of these frames here. By the way, our memory settings have set to minimal to other programs, so we can get the most RAM used on Premiere Pro. So it's fine as well. This is now H.265, okay? And this should be accelerated on the GPU, or usually it's played back on the NVIDIA GPU. Let's have a look at this. It's slightly choppy, so I don't know what is going on. Actually, it's quite smooth in here. When we're pressing play, let's see what plays it back. As you can see, it was played back on the actual GPU here. This video codec, it was played back there. It's played back there. The CPU is very much idle. So I'm happy to see that the Radeon 7950 XTX is playing that back as well and doing quite a good job. This is quite smooth here. Now this is the interesting point here. This is Canon R5, 60 frames per second, 10-bit 422H.265, and this usually is only accelerated on the Intel QuickSync. Let's press play, see what happens. What is playing this back? CPU. As you can see here, the CPU is very much utilized here. We are pulling 162 watts to play this footage back, and we have dropped 12 frames. So that's the place where Intel actually has an edge here, and because Intel iGPU plays this back and consumes hardly any wattage here, but this is very, very, very CPU heavy here. Codec can't play that quite back. Come on, and it's taking a lot of time to load this back and then play it. We're dropping frames, as you can see. That's not ideal. Okay, 0 frames dropped, and look at that, 30 gigs used on the RAM as well. This is not ideal. Canon C200. Wow, that is very, very, very smooth. So this is 60 frames per second, Canon C200, Canon RAW. Well, it took some time actually there to play this back. Let's play. Whoa, what's going on here? It's absolutely struggling. This is interesting. Our 13600K with an ARC A380 was playing this back. Have you seen that video? Look at that. 0 frames dropped. That 13600K is seriously impressive. But here we are dropping some frames. This is ridiculous. Look at that. This is really hard for AMD CPU to do. This Canon RAW is absolutely killing it. Okay, this is 2 Canon RAW clips on top of each other. Look at that. That is crazy that it can't do that. That is very, very surprising. Now, Red RAW, on the other hand, should be very, very easy for AMD and playback. What? Look at that. It is struggling. That's the thing. For some reason, it can't debayer that red R3D. Even 4K this is. I mean, it is quite smooth, you know, but we're still dropping frames, which we didn't see even on the 13600K with A380, which is very, very surprising for me. I literally just updated the AMD software as well for the GPU. The timeline is very, very smooth, but unfortunately, it's a no. Now, this is 120 frames per second, 420, 8-bit, 4K H.264. Let's see what plays this back. Video codec. Okay, so this gets played back on the GPU, accelerated by the GPU. And the GPU is slightly dropping some frames, 9 frames dropped there, but quite smooth playback still. So it is able to decode that. I can hear the GPU going. They're making interesting static noises there. Timeline, very smooth though. I'd argue one of the smoothest I've ever seen, in fact. And this is 422 10-bit. This should go on the CPU. Yep, look at that. We'll see the CPU there going. And we're dropping loads of frames. Look at that. Timeline is not smooth at all. H.265 420 10-bit, 120 frames per second. And look at that. That is that's the media engines on the GPU playing it back, but they're not doing a good job. Look how many frames we're dropping. So many frames. H.265 is no good. Intel was a bit better doing that. And 422 10-bit H.265. Oh my word, this is CPU only, isn't it? How much power are we pulling? 153 watts. Nope. So only 420 8-bit was the one that was good for 120 frames per second. The rest of them, I think Intel was doing a better job. So this is 5K Red RAW. scrubbing through quite good. When you're pressing play, goodness me, this is worse than 7950X. So there's some kind of driver and software issues going around with AMD in this. That is seriously crazy. So looking at 6K Red RAW now, full resolution. It's just not handling it. Look at that, the CPU is 100% pegged there. Can you see, pulling 225 watts from there and it's not able to do it. Scrubbing is quite all right. Let's see without color grade. No. Honestly, I am very surprised that this is like that. This is some red Komodo clips. Actually, this is a little bit better footage. I'll give you these stats here as well, so you can, if someone's interested, can look at this one. And then the other one with the woman there on the, was this as well. So you can have a look at like the kind of raw settings there. One was Red Dragon 6K and one of them Red Komodo 6K. This PC footage, exactly the same. CPU goes to like 100% and then can't quite play this back. Whether it's with color grade or not. It's struggling. B-RAW, that's usually very easy to play back. Blackmagic RAW, pressing play shouldn't be a problem. Yeah, no problem playing this back. AMD definitely needs to do some optimization and work with Adobe, making sure their programs and their CPUs work well with the program, but right now that's no good. Let's have a look at Canon R5 8K. So first of all, full resolution, press play. CPU 100% utilized. Uh-oh, please don't crash. Okay, that is definitely no good here. Half the resolution. Okay, there we go. The scrubbing is quite okay. Pressing play now. Takes time and still drops frames. Now timeline is okay, but playing back is no good. Quarter of a resolution. Scrubbing is very, very smooth now. Pressing play still takes a bit of time. Plays back. Drops an odd frame. Is alright. Definitely not the best performance I have seen. Now, this is Red 8K. And usually I've seen AMD CPUs be very, very good at this. Let's press play full resolution here. Let's see what happens. I mean, this is crazy. It's still stuttering. I have played this back on a 16-core AMD CPU with no problems. The timeline performance is alright, but when pressing play, so scrubbing is okay, but when you're pressing play with the color grade, look at that. CPU 100% utilized, but then it pegs itself down. Here we've got 12 gigs of GPU memory used. As you can see, we're using 45 gigs of RAM. It's not the best performance. And lastly, this is a 12K, okay? Let's see what happens when you press play. Full resolution 12K. With color grade, CPU 100% utilized, memory 57, 59, 61, 62. Okay, all RAM is used now here to play this back. Half the resolution. It's getting there, but still dropping some frames. Timeline is quite smooth now, so you could easily play back half resolution 12K B-RAW. It's alright. And when we could put it to a quarter resolution, It's very, very buttery smooth. Pressing play, no problem for the CPU. Now, as you can see, iGPU didn't do much. Now, even though AMD has the iGPU as well, we didn't get any benefit from it. And AMD could work with Adobe or some of the software guys to actually make something the likes of AMD QuickSync or something like that, so that we can get some utilization of the encoders of the iGPU as well. The GPU 7900 XTX was doing okay, but it's still like limited decoders there, so it doesn't play back all the footage that like Intel QuickSync or something like that can do. And I know I sound like a broken record praising Intel, but when testing these things, yet again, I'm seeing why Intel works better in these programs. Obviously, AMD shines in some of the other things, but right now in this program, that's the one. We've reached 91.8 degrees, roughly. We've pulled 232 watts maximum from the CPU socket. And here, again, you can see the minimum we have reached is 42 watts, okay? I'm gonna close this as well. So there's literally nothing running apart from this hardware info. And you can see that the package power is still 56 watts, 42 watts, 41 watts. Let's see if it goes any further down. That's the like AMD idle power consumption issues there. We didn't do any thermal throttling, which is good. We've reached 96.1% of the thermal limit. And let's have a look at the GPU now. The max temperature we hit was 59 and memory was 74, which is completely fine. We pulled up to 248 watts, or total board power, 296 watts we were pulling there, which is quite interesting. And if we're looking at the memory utilization, maximum utilization, but BSOD. So we used up to 16.8 gigabytes of that RAM. So what do I say? Am I impressed or not? To be honest, not really. If you remember the test we did with the 7950X with earlier version of Premiere Pro and a bit of a lower end system with DDR4 and 5950X, which is like the previous generation of this CPU, have a look at that video. You can see that it was playing back a lot of these footages much better than right now. So that shows that the new architecture hasn't quite slotted in with, you know, Premiere Pro, for example. So if you're a video editor, maybe hold your horses. Now, I'm not saying you can't do video editing because some of the 4K footage was completely fine, but above 6K, that's where the usually Ryzen, you know, 16 performance cores shine. It was actually very, very insignificant and not very impressive at all. If you want to see the PC build of this PC, check it out in the description below, where you can also find the parts that I use for this PC if you want to pick any of those up. As well as if you want to build yourself best bang for buck creator PC, then check out the build guides in the description below. Whatever budget you have, there's a build guide for you. You can configure it to your needs, upgrade, downgrade it, so you can get the best performance creator PC for you. I'll explain everything in those videos down there. Go check them out, completely free. Just go and enjoy. There you go, the best PC you can build. Bye bye.